Carter. You guys all just saw me over there. And this is Jack.
My name's Jack Rintjema. I'm an automation consultant for Gerrie Electric.
So I handle the automation software for Gerrie Electric. And when we're putting this seminar together, this is where data collection came in, because we often get asked, oh, I need something for reporting. I need something to collect data. And that's all we get from people, and that's usually all you guys get from your customers or from your anyone else who's asking you for these reports. So we kind of wanted to cover scalable approaches from the small, medium to large systems, because you don't always need this gigantic enterprise-wide. I'm looking at 15 different facilities. Sometimes you just need reporting on one machine, a small machine. Right? So when we talk about data collection, Jack and I wanted to go over the basics of data collection, because just saying I need data or I need reports isn't enough, right? So the first question you need to ask is, what type of data are you collecting? Are you collecting, binary bits going on and off? Are you collecting values? Are you collecting strings? What type of data do you need to collect? Where does it need to be stored, right? Are you storing this in a PLC, in an HMI, on a server? What are your restrictions there? How long does it need to be stored? Are you in an industry where, for example, food or pharmaceutical, where you need to keep records for 7 years? Or are you just doing this for internal use and you only need 2 weeks worth of data, right? There's a big difference there when you look at that. And then what do you want to do with it? Do you want to report it, or are you just collecting data in case someone needs it in the future, right? Because sometimes that is what you need. I'm just keeping these records in case someone asks. We all do our taxes every year and kind of just file everything in case the government asks for it, right? You may not need to have that information constantly available, but you need it. And then how do you want to present it? Who are you showing it to? What does it have to look like? And what format are they expecting the data in? If you're talking to a high-level executive at your company, they're probably not going to want to go through an Excel spreadsheet with like 10,000 entries. They're expecting the information quickly and easy to read. Right? So when we talk about data collection, you might look at your automation system like this. Okay, I've got a PLC, I've got a drive, I've got an HMI, I've got maybe a computer in there. That's like 5 things I need to collect data from. I need 5 data points. When in actuality, when you look at it, there's a lot more data there, right? You've got all the parameters from that drive, all the parameters from that PLC, maybe extra parameters in the HMI and the computer and everything else. When we look there, machine state, part counters, energy usage, batch data, faults, do you want to track full OEE type of data? These are all the questions that you need to consider. It's not just a couple tag datas that may be present in the PLC.
So before we get into specific solutions, provide a bit of a background around data collection concepts. All right, just to make sure we're all on the same page there. All right, by very definition, data collection, what is it? Well, it's just collecting information and storing it somewhere, all right, for the purpose of course, future analysis. All right, now what's interesting is there's many disciplines that actually collect data. It's depending on what job function are, your data collection requirements might be quite differently, right? So if you're a maintenance versus production person, the type of information that you're after and that you're interested in is going to be different, right? So you can see I have a list in my travels of the different departments within a manufacturing facility that might be interested in some sort of data, right? Maintenance, production, quality control, operators themselves, right? And the management teams, whether it's from the production side or upper management, they all have specific types of information that they're interested in. All right. Now, what I found is that in the past, what's happened is that these groups tend to operate independently somewhat of each other, and it's not unusual for each one of these groups, one or more of them, implementing their own data system. Buying a product or something that suits that specific set of needs. All right. I don't know if that's your experience, if you have some data collection experience in your plant already. Right. So that's very, very common, and that continues on as well. All right. Other way? Which is okay. This way. All right. All right. See, here are the fundamental steps. Again, not being product specific, but fundamental steps around which we need to address to collect data. The very first one is capturing the right information. I have been in these meetings where there's interest, you know, Jack, can you come in and help us to understand what we need to do for collecting data? And what Amy had mentioned earlier on is people can't answer the fundamental questions. Okay, what data do you need to collect? You know, how long do you need to store it for? All right, and answering those questions is very, very tough to do, right? And what I have seen happen in the past is because there's not clear definition of what you're going to collect, well, let's just collect everything. And you end up with databases with lots and lots of information. As you probably know, information, vast amounts of information can be accumulated very, very quickly. All right, straining resources like hard drives and file servers and things like that, right? So it's important to define really what kind of information do we want. And of course that relates to the type of person you are and what your job role is. You know, am I maintenance or am I production, right? And what do I need to know? Okay, then the data is stored. All right, we'll review that in a minute. Once the data is stored, that's fine. I'm surprised how many people store data, but they never ever, you know, retrieve information out of it. All right, again, saying, well, did I store the right things or not? It's kind of like, you know, collecting stuff in your garage. You know, and you're a tool guy, so every time there's a sale at Canadian Tire, you buy something, and it still goes on the shelf, and you never use it, and you forget you even had it. Right? I've had that before. So, but we need to be able to understand what data is there. So that's where it takes us to, you know, be able to, you know, retrieve that data, all right, contextualize and apply analytics to it, right? Make sense of it. Need to start sorting it, right, and organizing it in a certain way so that I can actually get meaningful information out of it, right? That allows me to start making decisions, right, regardless of what my role is, all right? And then the last step is I need to visualize it somehow and have it organized properly, right? And that's about how do I display it on my screens, on my phone, all right, on my information device. So these are the steps we think about. And many times, the technologies behind these steps are not always the same pieces of software. It could be from different companies even. All right. Another concept around data collection, another fundamental, you probably know this, but I thought I would cover just in case, is the idea of pulled versus pushed or stored forward. Pull information means that there's a computer and it goes out and asks from our factory devices, please send me this, all right? So it might be as simple as polling for temperature every 10 seconds, right? The server goes out, give me the temperature please, and the PLC will send it back, all right? And it repeats it over and over again, all right? An example of a store and forward or something called pushed means the PLC would have the temperature, and rather than the server asking for it, the PLC just sends it to the server, even though the server didn't even ask for it, all right? And that's called a push. So it's kind of, oh, well, do you really care, right? Because in both cases, the information ends up in the database. So what's the difference, though? And the key is, with the pushed model, I have the ability to be more efficient, right? Only push when the information is necessary, as opposed to just pulling it and storing it every so often. All right, allows us to store data that is useful as opposed to irrelevant data. All right, and the other critical thing is the ability to save the data if, say, the connection between my factory device, whether it's a PLC or a drive or something, and the server is lost. Maybe it was a network connection, or maybe the server is remote, off-site, and it's not immediately available. Well, do we lose the data or not? Maybe it doesn't matter, all right? But if the data is critical, all right, and I need to save that, maybe for reporting requirements, for quality requirements, or ministry requirements, or something like that, regulation requirements, all right, I can't lose that data, all right? So the store and forward model is a good model to put in place so that I don't lose data. The reason I say that is because if I do lose connection to the server where the data is actually stored, what the sending device would do, all right, is keep accumulating the data, all right? And when the server becomes available again, all the accumulated data is sent in mass over to the server, all right, and being stored there, so I don't lose that information. So that's the key difference then in the concept between pulled versus pushed. In a pulled model, if I lost my connection, I would simply lose my data. And there'd be a blank window in your data set, right, where there's no data available. All right, storing data, there is different methods of storing it as well. All right, for small solutions and simple solutions, and often a common method to do that is storing in log files. A log file is simply like a text file or an Excel spreadsheet file or something like that, CSV file. All right, and it can be useful for small applications. All right, as the data requirements become larger and larger, you get into problems like, okay, how big can a single file be? All right, does it create new files automatically for me if the file gets too big and things like that? All right. The other choice is putting data inside a database itself. All right, that might be relational databases. Again, it could be something from simple to a Microsoft product to more elaborate products like SQL Server, or it could be a proprietary solution from a vendor, say for OSI Pi or FactoryTalk Historian from Rockwell. All right, and then the other thing is where do I store it? Right? Is it stored on premises? Is it stored at the local panel in the machine itself? Do I store it on a file server in the office? Or is it stored in headquarters on a remote server? Right? All things to think about around that. And then, of course, today there's even this choice of cloud-based storage. Right? And does that make sense? And is that allowable? Or does the culture of your facility, allow you to do that? Now, another concept is transactional versus time series data. All right, you see I have three types there, transactional, time series, and event data. All right, there is a fundamental difference there. And what I'll do is describe transactional for you. Transactional is data, is a method of collecting data where the server and the source of the data talk to each other in such a means that assures that the data actually got into the database. There's actually checks in place. All right, with typical time series and event data, all right, those checks are not there. All right, an easy way to think about it is for transactional data is, for example, using your credit card. All right, I go to the gas station, and I put in my credit card. You got to put in your credentials. All right, there's communications with the server, they validate that. Let's say in the middle of that, communication is lost. All right, what they do is invalidate the entire transaction. You got to start all over again. Take your credit card out, put it back in, and it's going to ask you again, right? So that's a transaction. It's ensuring that all the steps needed to get the data from one spot to other are in place and they are correct and they are secure. All right, so that is one method of collecting data. The time series data typically doesn't do the transaction. One of the reasons why is because transaction data takes a lot more time to store the data, right? There's all this talking back and forth just for even one piece of data. All right, so time series data, maybe I want to record data every half a second or maybe a quarter of a second in some cases, or very, very fast information. Well, you don't have time to do transactions, right? But then a loss of a single piece, a single measurement might not be critical either, right, with this type of data. All right, so that's the key difference there, and depending on the transaction types, software will support one or the other, or perhaps both.
All right, so I'm going to talk about reporting on the small scale, right? So as we go through this, we're going to talk about small, medium, and large. So when we talk about small reporting, small data collection, we're typically talking about things that maybe on a PLC, maybe they're on an HMI, and they're primarily going to be used by operators and maintenance, right? This isn't something you're going to have the high-level executives at your company gathering around a panel view or looking at an Excel report to look at this data. Right, so the overview of how the system looks is you've got your PLC and you've got your HMI, right? PLCs are capable of storing data, but you really have to think about how much data you're recording, right? Because your PLC is also doing other functions like, running your machine. So if you're gonna, be recording a lot of data, you're gonna fill up that PLC, you're gonna slow your cycle time, you're gonna possibly have problems with the running of your machine. So what a lot of people do is the data. So the data source is controller tags or HMI tags, right? You're going to pull that data and typically store it in your panel view or your HMI, right? Your HMIs are all capable of storing data in data logs, in CSV files, and you can save that on the hardware itself or onto a server-based storage as well, but it will be formatted in a CSV. You're not going to see a panel view put out this beautiful report that you can then pass on to the higher ups of the company. It's primarily for troubleshooting, right? As I said, the maintenance level people. And when we talk about something like this, it's not easily expandable because you're setting up something in an HMI that's just pulling data from a single controller, maybe two controllers, right? Excuse me, but that's the limitations of it. You're not going to go plant-wide and record data for your entire plant on one single HMI device. It's just not doable, right? You're going to overload the machine, you're going to overload your data files and everything else. And the one thing we like talking about when we're talking about scalability, as I said, you can't do this plant-wide. I mean, you could have multiple HMIs within the plant, but then you'd have to go and source the files, put them together, analyze that data and report it, right? It's a lot of work. There's a lot of engineering effort involved in this because you're requiring the person who programmed the PLC and programmed the HMI to get that data for you, right? The engineering effort is high, whereas some other solutions, there's more, computer software based or, SCADA or enterprise level reporting package work and not so much PLC work. This is machine specific because you have to go into that HMI itself and set up that file for that HMI for that PLC. It requires an intimate knowledge of how the machine works because you have to know those data tags, know the type of data you want to record, and bring that all in together, right? So when we look at this, it's a lot of effort. Has anyone tried to do this before? Yeah. And does it take 5 minutes? No, it's going to take hours, right? And hours and hours. And I mean, it's great for a small scale solution, right? If budget is your limitation, or if it's just a single skid, a single machine, the customer yourself, you want one thing, isolated, island of automation, it's never going to go into a plant-wide system, this is a good option, right? But we really have to talk about things to consider, right? Your considerations or limitations, things you have to think about. Smaller, simpler reporting needs. You're not going to take this on a large scale plant-wide, right? But it is good for the simple OEE data collection of that system. What's really nice, if you're using a panel view, it has a built-in viewpoint server, so you can actually go mobile very easily. When you go into that panel view, you choose the displays that you want to publish to viewpoint, and if there's a mobile network nearby, you can hop on your phone, go to the IP address of the panel view, and get that data remotely. We've had a lot of people recently, actually the past couple months, on the plant floor. They want a TV above the machine showing simple OEE data, production data, right? This is a very easy way to do it. It's a very cost-effective way because you just need a smart TV or a smart monitor, right, that's capable of going online, connecting to the viewpoint server, and it shows your displays, right? As long as the panel view's up and showing that data, you can have that. Right? So it's a very, great entry-level system into the reporting environment, right? There's a lower initial investment because you are working with smaller cost hardware, but as we said, substantial engineering effort, hours upon hours to get this to work, as opposed to something where you have a more structured database, right? Because this is just text files. Someone's got to read this text CSV file, maybe put it into Excel and deal with it, right? And when we're looking at how we display some of that data, maybe you've got a panel view trend, and these are great to follow, right? Everyone can tell what's happening with this. They're great, they serve a purpose, but in terms of visualization, operators, maintenance, people with intimate knowledge of that machine know what's going on with this. If this was a machine on your plant floor and you know what those variables are, this is a great solution for you. Again, small scale, isolated system. But in terms of bringing this data up to the executive level, that's not going to fly because this isn't very easily understandable to anyone outside of this role, right? And then we're going to get on to the medium reporting options.
So when we get into somewhat larger systems, arguably, in a sense there's shades of gray. There's no clear defined cut between small and medium and large, I suppose, right? So and a medium solution can even wander into the small space if that was required as well. all right? But the characteristics there is that you have a lot more options, a lot more flexibility, a lot more capacity, all right, for being able to store, retrieve, analyze, and report, all right? So typically your data is much more managed. For example, one of the solutions here might be using FTView, a SCADA system, right? Which has built into it, in addition to operator displays, has a built-in data collection and storing capability, all right? And what you can do there is you can actually create log models. Remember my very first information about collecting the right data, right? And the idea with creating log models is you can create a model of what data that you want collected together, even though they might be from different locations, might be from different PLCs or whatever, but the data is related to each other. So that's the data I want to store together as a group, all right? And you can create many, many different log models of data that might be related to each other. So depending on a person's role, for example, in the plant where there's maintenance information, that might be a certain log model of data that's important to maintenance. But from a production supervisor, they may have a different data set, right? So you can create a log model of data collection for that type of person, all right, and also store that away, all right? So in this situation, it really opens up the type of choices that you have there. You know, a SCADA is one method of doing that. There's other ways as well. I've had customers that have used Excel as a means of data collection, which is rather odd, all right? Excel is not really a database, all right? But you know what? That doesn't mean it's to be dismissed, because it has its role, all right? What you can do is you can use Lynx OEM. Lynx OEM, if you're familiar with some Rockwell products, there's a product called Lynx, which is able to talk to the PLCs and devices, right? So at one end, it'll communicate to the PLC, but at the other end, it's able to talk to Excel. So you can actually take data from your PLCs and populate Excel spreadsheet fields with live data coming from the PLC, and that can be stored as a spreadsheet, and of course you can add all the pie chart and fancy Excel reporting capabilities to be able to report that data intelligently.
But that is not easy to do.
It's again, it's an engineering effort to do that. All right. Another example of more flexible area here is something called Transaction Manager. Have you ever heard of that software before? Have you heard of it? Maybe have you used it perhaps? Yes, yeah. So it's a highly flexible way of building data collection. What's interesting is Transaction Manager, as the name implies, it is able to do transactional databases to ensure that data that you collect is deposited in the database, and if something breaks in the transmission of that, all right, it knows that, reports an error, and attempts to do it again, all right? So these are the things that we can do there. Manual report generation is required for solutions like this. A lot of times these solutions are used by either engineering, maintenance, and quality personnel, all right, for reporting purposes, all right? Some considerations, all right? Because the data, you have a lot of flexibility as to how it's stored, typically either in custom files or in an actual relational database, all right? Once the data is in a relational database, you have a lot of connectivity options around integrating it with other type of software, all right? There's some capacity limits there still, right? For example, if we ever use FTView, it has some capacity limits, although it's quite high, right? And when it says 20 log models, 10,000 tags, that would be not the total amount of data that we can collect, but the amount of data that we can collect and put on scan at the same time, all right? So even with that solution, you can collect a lot of data in a short amount of time, depending on how quickly you do that, right? Typically, we're storing our data on site, right, inside local servers, local computers, all right? It is possible to do it remotely, so it's not like it's impossible, but typically it's more local data because it's people that want more immediate access to that information as the type of people that would use it, all right? Secure connections required if you do need to view it remotely. All right. And the amount of investment, I would say it's certainly less effort, at least in my experience, than say using a very simple solution like Excel with Links OEM, or maybe even a small solution. All right, so the engineering effort is smaller there. And in terms of reporting, native reporting was typically trends, right, within the HMI systems.
I just want to point out that these trends are much easier to follow
well,
than the previous trends. You know, we've got some reporting capability. You can see when you've got alarms triggered and where the variables were.
So yeah, so this is a good example where it's not just trending a temperature, for example, or a pressure or some other parameter in a plant, but we can actually trend and link the alarm data along with what we're trying to trend, right? And it allows us, from an operations point of view, to do some analysis as to, you know, how are they related? Or is there an unrelated alarm that might be related to the data? So this is the idea of analysis. And what I really like about this trend is that in the past, as an engineer, I had to design these things. I had to be smart enough to say, okay, what might the operator want to see? And chances are you might have even spoke to the operator and asked them what they wanted, right? And sometimes you don't even get that opportunity, so you have to guess, all right? But in the case of training here, the operator can draw their own screens while the system's running, all right? So now all of a sudden as an engineer, I'm not stuck guessing anymore. So if the operator says, okay, you know, I want to compare this value with this value and see what that looks like, because it seems that something's going on, and they have the freedom to build that trend while the system's running, all right? And they can save that, right? And they can call that back up if another operator comes up on another shift, all right? So it's a nice way to do that. Not all data can be looked at as trends, though, all right? So you have also the ability to export a range of data and drop that into a spreadsheet, and once again using that environment and its tools to be able to do some analysis there. All right. Excel Reporter, that is actually name of a product that is an add-on to Excel. Most people will admit that Excel is an excellent tool, right, because of its flexibility. But if you're using straight Excel, guess what you have? When you turn it on, you're faced with a blank sheet. And now what do I do, right? So Excel Reporter is a product coming from a Rockwell and Compass company that has an add-on to the Excel basic software package that allows me to generate reports very, very quickly with predefined templates, right? Easy to reach out into the databases where the data has been recorded. It has connectors for that, all right? So I don't have to build those into Excel like I would normally, all right? And be able to extract that and easily have rules under which I can extract. You know, for example, at time frames, there's this typically extraction rule to say, hey, can you give me the data from last month, right? And put it over here, all right? And it provides me with predefined reporting methods, so I don't have to learn all that stuff in Excel. It's a very, very nice way and fairly cost-effective way as well to be able to quickly generate reports.
And I'll admit, I had never heard of this until Jack brought it to my attention, and looking at this software, it's really powerful.
Yeah,
there's a lot of stuff in there, and as you said, you're not starting with a blank slate. You've got some templates to work with, right? So that moderate, you know, medium range application where you don't have the higher budget and the bigger software packages, this is a fantastic option.
Yeah. All right. So we'll look at large systems.
So large systems, right? So now we're talking, you know, when Jack was talking about medium systems, that can also be plant-wide. That doesn't have to be limited to one machine, right? So the first one, small, we're talking about, you know, a small machine, a small skid. Medium, it could be a machine, it could be a line, it could even be plant-wide, going with things like that. When we get into, you know, the large data collection services, it's definitely plant-wide. It may be multi-site, it may be multi-locations. Maybe you have a facility here, you have a facility in the States, you have one, I don't know, somewhere really fun where they make cookies or something. I really like cookies, by the way. Right? When you get into these larger architectures, Data is output in standardized formats. So you're going to be dealing with, something like a SQL database. You're not dealing with a CSV file, right? You're dealing with data in standardized formats that can be read by multiple packages, right? All of that collecting of the data is handled, and that organization, that analyzing of the data, a lot of that is taken off your shoulders and handled by the software itself, right? It's prepared for those tools, and you don't need to have that intimate knowledge of the machine. When we had the small scale ones with the HMIs, the guy programming the HMIs is doing that, right? If you're doing that HMI and tomorrow you leave, it's a lot of work for you to pick up on that, right? Because you're learning about, or you're setting this up with the reporting tool itself, you need to have knowledge of the reporting tool, not so much the process. I don't care how your plant works. This is the data I'm pulling in. This is how you want to view it. I can set up the reporting for you, right? It allows a little bit more freedom, and you can specialize on that tool itself. Right? And it's not machine or SCADA specific. These are agnostic reporting tools we're talking about. When you get to this larger scale system, it doesn't matter which PLCs or which other software packages or databases you're connecting to. They have connectors to bring all of this in, right? When we talk about collection, you can keep these on redundant servers, typically large scale you would, so you wouldn't be losing any of this data. And earlier when Jack talked about that push data and that store and forward, this is where you would see that type of system, because you don't want to lose that information. If there's high speed, that buffering, we've got something called a Historian ME module. It's a module that fits in the ControlLogix chassis itself, and it does that store and forward for you. So it takes all the data across the ControlLogix backplane, buffers it, puts it out to the Historian server as needed. So if the server itself goes down, you've still got that data collection happening, right? And you would see that more on a system like this. The collection, again, it's on that node or on the server. And this is where we can get into, we would typically see larger servers. That medium one Jack was talking about, you would typically see a server PC, maybe a tower-based server. This, we're talking large-scale servers, like the one we had in that room, the 24-inch wide, going in an industrial data center or a server cabinet rack itself, right? And then when we're displaying this, we would be displaying this on like a Vantage Point or that type of enterprise-level software. Moderate engineering effort, because someone still has to create the tags in the PLC. The data still has to be there. Someone has to make that relationship between which data needs to go into the software tool. But what's nice is when you go into a large-scale system like this, no matter what your future reporting needs are, everything's there. Right, Jack's medium scale system can be scaled up into something like this, right? The medium level systems are fully scalable to go into this larger plant-wide system. So it's a good starting point. It's a nice dip your toe in the water before you go into something like this. But here we get into automatic and ad hoc report generation, right? So automatic, every Monday I want production data sent out with charts, reports to this person, this person, this person. Okay, the ad hoc, manual report generation. Maybe today there was an issue on a machine. I want to click a button and pull in that data. You can with this type of system, right? The idea is it's pretty hands-off. It'll manage itself when it's set up. It doesn't require a lot of interaction. And it's primarily used by operations, quality, and management personnel, right? The people that want to see all of that data visualized together, right? Some considerations, if you were just implementing this as opposed to scaling it in, it is a higher initial investment. Right? Because you've got to have the bigger hardware to handle that. The more storage space, either locally or cloud, you're still paying for it, even though it may be in the cloud. But there's a low additional engineering effort to add on more reports, because you can do all of that in the reporting tool itself. If you were using a reporting tool like Vantage Point, anyone here in this room would be able to manipulate reports to show the data they want. Right? You're not going to hit a capacity limit. The only capacity is dealing with the storage on the server. Swap out for a larger hard drive or pay for more cloud storage space, and you've got that available, right? And it just gives you that flexibility that you don't have with the smaller systems. So if you need to do reports for, specific quality reports, engineering, maintenance, executive level reports, everyone wants something different. Everyone wants it formatted differently, and everyone wants to tweak it themselves. This is, the type of system you would be going with, a large-scale reporting one. And that multi-site capability, so if you have facilities in different areas, this is the way to integrate that. Jack?
There we go. Takes us in the world of reporting, right? So we got the data stored. What Amy just described there was a very comprehensive system. of storing data. One of the key products there, of course, is FactoryTalk Historian. Has anybody used that before, FactoryTalk Historian? Have you? Okay. All right. Have you ever heard of OSI Pi? Yeah, so FactoryTalk Historian is, in fact, OSI Pi technology. All right, the product from Rockwell. All right, and I've done many systems using FactoryTalk Historian, where FactoryTalk Historian was really just a smaller system, and the customer already had OSI Pi. I was just amazed in my travels of how many customers I ran to that are using OSI Pi as their historian solution for plant-wide applications, right? And what was really neat is that when I sold a small automation system, there was requirements for just local data, even though there was a bigger plant-wide system in place. So even though they had that, we still sold a smaller FactoryTalk Historian, and they would serve the operator needs for local trends, short-term trends and things like that, historical stuff. At the same time, the plant management had access to that new installation because our small FactoryTalk Historian server would tie in directly into the OSI Pi main server, right, and transfer the selected data as required, right, and just interfaced seamlessly. So it was a beautiful solution in many, many cases. All right. I love that little Historian ME module as well, the one that plugs into the rack. Because it goes over the backplane, it can collect data really, really fast. I had a steel mill application that I'd done up north, and they were doing gauging on one of the rolling mills. And if you're familiar with a rolling mill, it goes really, really fast. Data comes off the gauge really, really fast, so you need to collect it though. All right, and the Historian module was able to do that, right, and store it into the Pi database. So a lot of great applications around that. Around reporting with VantagePoint is, this is the thing. We talked about different data storage options, but, all right, as I mentioned earlier, there's almost always, in every plant I visit, there's different departments that have built their own database of their own information to meet their own requirements. Often it was quality. Quality people tend to operate in a world of their own, right? And, you know, they need to do their thing, right, to do that, and justifiably so, right? So, but the problem is when I'm reporting, especially as I reach more upper management type of things, is that intelligent decisions require me to relate data. You know, how can I relate process data, might be temperatures, inside my historian database? How do I relate that to the quality database in somebody else's server? And how can I pull those data sets together and say compare, all right, to draw conclusions from that, all right? How do I then relate that to cost? Well, where's the costing information of some of the things I'm making? Well, it's in an ERP or MRP system, right, somewhere. And I want to be able to pull in cost data, pull in quality data, pull in production information, all right, process data, and pull that together. And is that going to tell me something about my operations around efficiency, all right, and things like that? So that's what VantagePoint is really about. All right, it goes beyond just the individual database and allows me to reach into multiple different databases in the plant, all right, and pull them together, all right, and then I can start drawing charts and drawings like you see on here that actually come from completely different data sources that normally you think, well, they're unrelated, but in fact, from a business perspective, they are, all right. So you can see, you know, a selection of bar charts, pie charts, numerical data, graphs, and they could originate from historical data. It could even originate as live data coming directly from a PLC. All right, and that combined with other database information will produce meaningful information. Right?
I always think it's funny when you mention, you know, the different departments out there and that they don't communicate. It's true, because how often do you forget that other people exist outside of your own little world?
Yeah, well, that's true.
Like, you know, we're all in the, I think everyone in here is a controls person. You know, you're in the engineering mindset and you're concerned about production, keeping everything going, and, you know, your experience, every time, there's no quality people, right? Okay.
Yeah.
Every time Jack mentions quality, I'm like, oh yeah, everyone has quality, but you don't think of that because you're so concerned about your needs, and that's exactly it. When everyone else has a different system, and maybe quality already has some of this, you could integrate and pull it right in there, right?
Yeah, for sure. Right. So interesting, right? So another example of enterprise level reporting, and this takes us to an area where, as a corporation, I might have 3, 4 different plants, right? One in Toronto, one in Calgary, all right? And how can I pull those together, all right, to analyze the state of my business, right? And how is it operating, all right? So with the type of data collection systems that we talked about, it allows me to pull this all together, all right? I've been at many, even smaller businesses can have multiple sites. And I don't know if this is true in your organization. My experience is that even with multiple sites, over the years, they've all stuck in their own solution. So if you have somebody corporately that wants to, monitor and improve their business, and everybody's got something different, right? How do you pull that together? And it might be exact same information, OEE, for example. How do you pull that together? Yeah.
One of the challenges with multiple sites and multiple plants is they have different types of PLCs and stuff. So how do these solutions address the fact that you've got, 4 or 5 different types of PLCs, even in one plant?
Yeah, it's very true. So different PLCs and then different software to deal with, right?
Does the Vantage Point or any of these solutions address that?
Yeah. So what's really neat is that from a data collection point of view, that's where we're reaching out into the devices, right? The model of PLC probably doesn't matter anymore. All right, whether it's whether it's an Omron or if it's a Siemens or if it's a Schneider product or a Rockwell product, right? I would say, that's the truth for most plants, the honest truth.
Especially when you have
Right,
locations in different parts of the world where other
it'd be-
PLCs are dominant, right?
I've been in lots of Rockwell, centric plants, but even those plants have got this machine and that one in the corner, and it came in with something else on it, right? And okay, well, we're not going to spend money to replace it. So I just need to get a connection to it. So most equipment, other than, say, some older equipment, does have the option for an Ethernet connection. All right. I have also had machines that people want to collect data from, and believe it or not, are still using relays. No PLC. Do you agree with me that that might exist out there? Well, it does.
Pneumatic logic or something like that.
And there's no real way to get Ethernet in there, right? So in those cases, I would get a small, $500 shoebox PLC. We'd hook up some sensors to it in parallel with what's already running in there, and that gives me the source of the data to be able to get out, right? But typically, even with FactoryTalk View and things like that, it has data connections for probably every model of PLC you can think of. There might be some more obscure ones that may not be supported, but most of those data connections are all there. So I don't have to worry about that too much in my designs, right, to get that information. The question is, the other question might be, okay, is the relevant data inside the PLC, right? Is there parts reject? Is there a numerical data? I might have to do some programming inside there to actually generate the fields that I need to collect from, right?
I wanted to note, Jack, because you made note of, as long as it's Ethernet, we're good to go. If it is using an older protocol like DeviceNet or Remote I/O or Profibus or something, we have products called gateways, and gateways will take, the information from that type of network. So just because it's not Ethernet doesn't mean you can't get data into like an enterprise type system. It just means, you're getting another box to pull that information out. So there's a bit of a workaround.
Yeah,
Right?
I've seen customers, like there was I think it was an older GE PLC, not to pick on GE, but just an older unit, but it did not have Ethernet, right? And right away now you're limited, right? So what they did again is put a small PLC beside it, parallel up some I/O inputs, and ran with that, right? Maybe not the most elegant solution, but it worked, right? So, yeah.
So I just wanted to talk about here the customized dashboards, right? So when you get into these types of systems, you can't do a customized dashboard on a panel view, right? When you're in the medium scale systems, if you're using a SCADA system, chances are you can't do something like that either, right? When you get into these higher level reporting tools, this is where we can build customized dashboards specific to a person, to their job function, right? So you take a look at this, and this is an asset performance report for this machine. We're taking a look at the motor, and we're seeing a note, suggested action, excessive motor trips, you might want to repair this motor. Right? So we can do some analytics with these reporting tools. We can take a look at, the number of faults and, do a little bit of logic there as well. If the faults are high on this, if we're seeing these values outside of this range, let people know you should take a look at this, right? If this motor's running, at 60 degrees Celsius and it's faulting out every 20 minutes, you should go take a look at that before you have problems. Right? So that allows you to have these customized dashboards for everyone and put whatever content you want. That last slide Jack had with Vantage Point showed, Google Finance in the corner. That was pulling information from the internet and bringing that live into the report, right? So this is taking whatever data you have, you can manipulate it however you want and display it, right? So for preventative maintenance, this is a huge benefit for people because right now people are just, maybe they have a chart. Every 6 months, go and check the bearings on this machine. Every 3 months, maybe go change a shear or a blade or something on a line. This lets you kind of take a look at that data, report it, and develop real predictive maintenance, not suggestions, right? You could look at the machine, and instead of changing out a shear every 6 months, maybe it needs to be changed every 3 weeks. You've been producing sub-quality product for those 5 months until you've made that change. Right? So once you have this information and you start doing something with it, this comes back to Jack's earlier slide. When it comes to data collection, it should be useful and actionable data. Right? Now you can display that useful and actionable data in a way that allows you to do something with it. Right? And then this is an example of enterprise software integration. So has anyone heard of ER Portal? It's a CMMS software, so maintenance downtime, right? You can bring in those systems into this reporting tool, right? So we can take a look, at all of this equipment, all of the assets on the plant floor, and maybe decide, okay, this is where I'm going to generate a service ticket for this item, right? You can bring that integration in together because they're all reading, the database is the same, they're all accessing the same information. You're able to pick that from different systems. Right? So you can generate, from your report, if you're looking at that motor on the previous page and we say, okay, repairs needed, you can now click over to the other tab and generate that work order and dispatch someone out to do that report, right? Or to do that repair, sorry. You're not having to do a lot of manual work on this. You can even have the system auto-generate that. When that type of warning comes up, auto send out that, and then someone from maintenance can go look at that, right? I mean, the whole thing we're talking about today is efficiency. That's a pretty efficient process, not waiting until something breaks down, being able to get there before it does, right? And maybe even, prevent it and circumvent these common errors. I mean, everyone here's dealt with nuisance faults, right? Wouldn't it be nice if we didn't have nuisance faults, that all the faults we had were real problems instead of, just dealing with the issue and clicking reset and hoping it goes away?
All right, lastly, doing a bit of dreaming here. What if? Put our imagination hats on. I think everything that we talked about here, involves some work, right? Purchasing things, figuring out what do I need to store and what have you. All right, but I found that a lot of plants do not implement the best data collection simply because it requires so much effort. It requires people to look after it, to design it, look after it, make sure it works, and what have you like that.
Figure out how it works.
And there's costs associated with it, figure out how it works, how to maintain it, and what have you. What if we could have smart software that eliminated all those steps, the requirements to figure out what the devices are, figure out what data I wanted, to figure out how to store it, and I showed you all these different storage options, and then figure out how to report it. What if all that was done automatically and I didn't do that? All right, would a plant be able to implement something like that, and would they be willing to implement something like that? And so what I message here is that's in fact is what's happening, right? That's pretty exciting. That's what's happening right now, is that this whole data collection scenario that we've built out for you, all right, as we march towards the future, is becoming automated. Mentioned the word artificial intelligence right in our introductory session there.
It's not
right?
a scary word.
It's not a scary word.
It's not Skynet.
We've already launched one product that actually does this, right?
2.
And all 2. Yeah.
Logix AI was released yesterday.
Oh, that's right.
That was formerly
So,
known as Project Sherlock, if you've heard of that before.
Yeah, there's something called Shelby, and that's not the correct name for it, but
Factory Talk Analytics for devices.
It's really cool because you can put this box on your network. This box automatically finds the devices. I don't have to tell it what the devices are. It finds them on the network. All right, finds the PLCs, finds the drives. All right, it knows how to collect the information from them because it already knows what those PLCs are. They're not new devices, right? Same with drives. They already know what that information is, all right?
And this is the work we've been doing for years. It's just doing it automatically.
It's just doing it automatically. Stores that data for me and also puts the data in a format, reporting format, through web services. So I can just hit the box with my web browser and it gives me reports, right? And it's done all those steps that we talked about here automatically. Personally, I find that very, very exciting because it eliminates a lot of the, uncertainty, guesswork. It's really, really easy to implements in a very, very short amount of time. You probably have some experience with that.
Less than 5 minutes.
To put a box in and start generating, to the point of putting it in to generating reports. How quickly would that happen, right? It's just amazing, right? So it's very, very exciting, and that's why I wanted to talk about that. That product was specifically designed for maintenance people, right, to identify if the health of the specific devices on the plant floor. And that's extended, right, depending on different disciplines.
And what's really nice is because, you're talking about Shelby, it's a Rockwell product, so it started off with knowledge of Rockwell products, and it's now moved on to the Encompass partners, right? So it's moved on to, Festo and I think some E&H products as well. And all of this is exciting. It's fantastic to see this type of product in this world because normally when it comes to controls, we're like 20 years behind what the rest of the world is doing. That's actually one of the reasons I love Thid Manager because they support the HoloLens, which nobody else is doing, right? And we're not using today, but we will be using. But the exciting thing about this, and this is something, they're allowing some user-generated content into that. Right, there's still a lot of work people are doing, but if you, for example, are working with a specific valve or a specific sensor and you want more diagnostic information and it's in the sensor but the device isn't pulling it out, we can talk to the team and they'll make that connector for you. And all of the Shelby devices, because it's managed by a central database, a central firmware, all of the devices worldwide will benefit from you saying, I need this information from this sensor. Right? It's almost like crowdsourcing, but for industrial automation, because we know what's important, right? How often, when we're talking about different departments, how often are the people that develop some of the software we use using that software? The people that make our HMI software, our PLC programming software, are they ever using it? No, they're software engineers, right? They're making the software experience for us, but not using it. Right? This is a type of thing, again, emerging trends where they're allowing us to have feedback on it, right? And that is in itself exciting because this has never happened before with anyone. You're able to make that point that, yeah, I need this. My facility has 10,000 of these, or my company, Worldwide has 10,000 of these sensors and we really want this information. You can come to us, we'll be your, mediary, we'll go to them and we'll say, hey, they need this, and they'll get working on it. Right? That's cool. They've got a list of priorities, but we can jump in there if something's important.
Okay, we're overstaying our welcome here.
We have like 1 more minute.
Okay.
This is the last slide. I just get really excited talking about that stuff because normally we're, again, like 20 years behind the rest of the world. Machine learning, as we said, Logix AI, which was formerly called Project Sherlock by Rockwell, was released yesterday. It's a really big deal. In short, it monitors your process and makes recommendations to your process. Right? So if there's, control variables and you've got your process variables, it'll monitor all your process variables and let you know, hey, I think your control variable's off. It should be X or it should be Y. right? And this is a type of system where we've got this reporting, and we can see here probability of alarm in the next day, right? So we're taking a look at all of, for example, the lines, how often this line's going to have a fault, right? So this is using our ThingWorks. I don't know if you guys have seen Rockwell and PTC have made a partnership in the last year. Rockwell's invested like $1 billion in this company to bring ThingWorks into the FactoryTalk family, FactoryTalk Innovation Product Suite. And this is what it's doing. It's analyzing this data, and it's saying this line is probably going to have a fault tomorrow, and this is what you should look at. Right, being able to do some of this. This is, you know, the plan of the future. So when we're talking about efficiency, you know, in the other room I was talking about, you know, the next generation, you know, expects these plants to tell them when there's a problem, right? You don't have the guy who knows how the machine runs better. He has his own set of parameters. Now we've got the plant floor which can tell us how it runs better, right? Without a lot of human intervention.
Very cool.
All right.
All right, thank you for your attention. All right, we're always open to additional questions. You can speak to us individually.
Yeah, it's 10:57, so I didn't go over, just for the record.